Dear students, let us begin the second part of the lesson, in which you will be able to understand the importance of constructing the test statistics and obtaining the test critical value with a defined level of significance and a type of test. Students, here we are going to learn about test statistic. A hypothesis test takes all of the possible sample data and converts into a single value, which is called a test statistic. In testing of hypothesis, the test statistic value of sample data decides whether to accept or reject the null hypothesis. The test statistic compares data from an experimental group and control group. The sample results are expected from the null hypothesis or from the alternative hypothesis. The test statistic follow a sampling distribution. The corresponding probability distribution plots the probability value for obtaining the test statistic when the null hypothesis accepted. In the probability distribution plot, the shaded area represents that the probability value will fall in the given range. Estimating the standard error. To compute the confidence interval around the difference between two means, it requires to estimate the standard error difference between two means. Here we have four cases. The first case started with equal sample size with equal population variance. In case 2, we have unequal sample size with equal population variance. In case 3, we have equal sample size with unequal population variance, and in fourth case, we have unequal sample size with unequal population variance. Test statistics using standard error. Here, we are going to see the importance of studying the above said four methods. When the sample size is of the same cases, then we talk about first and second method, that they will give the same result. However, if the sample size are different, then we may produce different result. Here we are going to see that we cannot have the same population variance in all cases in reality. So we are going to see with an example. For example, a weight loss treatment might reduce weight in different percentage for each individual in the population. The distribution of weight may change before and after the treatment. Here the test statistics for the dependent sample is given by the standard error method. So we have t equal to d bar minus mu divided by standard error of d. So d bar is nothing but the mean differences, and mu is called the expected value from the null hypothesis. Standard error of d is divided by estimated standard error of the corresponding test statistic. Critical region. Here we are going to see what is critical region. In hypothesis test, critical region are important in deciding the range of the distribution where the value representing is statistically significant or not. Data scientists can define the size and location of the critical region by specifying both the significant level alpha and whether the test is one-tailed test or two-tailed test we have to apply for the corresponding critical region. Critical value. There are two critical values in testing the critical values. Here we can calculate which are table value and p value. There are two values, one is table value, another is p value. While one can get table value from statistical table, finding the p value is difficult. Hence, we are computing this through a statistical software. When we do manually, we have to calculate the p value only through a statistical table. That is going to come in the next slides. One-tailed test hypothesis test will have one critical value, while a two-tailed test will have two critical values. Graphically, it represents the critical value, which may splits the graph into two types. One is called by acceptance region and another is called by rejection region. For hypothesis testing, it helps to check the significance of the test statistic. Here the critical value is compared with the test statistics in hypothesis testing to determine whether the null hypothesis to be accepted or to be rejected. Here, if the calculated value of this test statistics is less than the table value, then the null hypothesis cannot be rejected. On the other hand, we have the calculated value of the test statistics which is greater than the table value, then the null hypothesis rejected. Decision rule. If the test statistic value falls in the rejection region, then the null hypothesis to be rejected. Otherwise, it cannot be rejected, it should be accepted. Steps involved in calculating the critical region. The first step we want to see, set up the null and alternative hypothesis for any T sample test. Second step follows, using the sample data and assuming the null hypothesis is true, calculate the value of the test statistic. To conduct the hypothesis test for the population mean mu, we use the T statistic, which follows a T distribution with n-1 degrees of freedom. Step 3 follows to determine the critical value by finding the value of the known distribution of the test statistic such that the probability of making a type 1 error, which is denoted by alpha, that is a Greek letter what we call by alpha, and it is called as the significance level of the test, is small, typically 1%, 5% or 10%, we write as 0.01, 0.05 or 0.10. Step 4, compare the test statistics with the critical value. If the computed value of the test statistics is less than the critical value, then the null hypothesis accepted. On the other hand, if the computed value of the test statistics is greater than the critical value, then we can say the alternative hypothesis is accepted. If the hypothesis is one-tailed test, then one can use the one-tailed T distribution table. Otherwise, we can use the two-tailed T distribution table. Here, match the corresponding degrees of freedom value, which is available on the left side, and the alpha level on the top row of the table. Then you can exit the intersection of this row and a column to give the T critical value. The given table is T table. In this table, in the top of the column, you can see degrees of freedom. In rows, we have one tail and two tail. One tail, we can have 0.1, 0.05, etc. up to 0.005. Similarly, two tail, we have 0.2, 0.1, 0.05, 0.02, etc. up to 0.001. The degrees of freedom, we have 1 to 25. So, in this, when you have a degrees of freedom 22, then the 5% level, then we have to see the two-tailed test, 5% is 0.05, the corresponding degrees of freedom 22, which gives the value of 2.074. This is the way we have to calculate the table value when you do manually. Here, we are going to see the test statistics for two sample T tests. The formula, which is given by T equal to x1 bar minus x bar 2 minus mu1 minus mu2 whole divided by square root of s1 square by n1 plus s2 square by n2. The T critical value is obtained when the population follows a T distribution. Here, the steps are already explained to you, which to find the T critical values are as follows. So, first we want to determine the alpha level, then subtract the sample size number by 1 to get the degrees of freedom for one sample T test. If we use two sample T test, we want to minus 2 for n11 and n21. So, totally we get 2. So, use the T distribution table for the alpha value to get the required critical value. So, here we are going to see the right tail test. So, in right tail test, you see this is the distribution plot. The right tail is given here. So, the middle we have the mean value of x. This is the 5% of rejection region, and this region is called by the acceptance region. Here, the critical value for conducting the right tail test, when we assume that h0 mu equal to 3 versus the alternative hypothesis HA, when mu is greater than 3, then the T value denoted by T alpha, that is n-1, such that the probability of the right of its alpha, it can be shown using either statistical software or we can obtain from the T table, that the critical value for T for 0.05 for the 14 degrees of freedom, we may get as 1.7613. That is, we would reject the null hypothesis h0 mu equal to 3 is not in favor. So, the alternative hypothesis h1 mu is greater than 3 is if the test statistic is greater than 1.7613. This is for one tail test. Similarly, here I give an example. This example will give you much more idea how to calculate the critical value. Suppose a one-tail test is being conducted on data with a sample size of 8 at alpha is equal to 0.05, then the critical value will be obtained by the following solution. When n is 8 for one sample t-test, degrees of freedom 8 minus 1 equal to 7. Using the one-tail test t distribution table, we get t value as 7, 0.05, that is 1.895. So the critical value is 1.895. Similarly, we can compute for the left tail test. The left tail test values are given as such what we have conducted in the plot. You can see which is part in the left side of the red region, which are called by rejection region. So here the critical value for conducting the left tail test H0 mu equal to 3 versus H1 mu is less than 3 is the t value denoted as t of alpha comma n minus 1, such that the probability that to the left of it is alpha. It can be shown using either statistical software or we can compute through a t table, that the critical value of t is given by alpha is equal to 0.05 with n minus 1 is 14. So we get the value as 1.7613. That is, we would reject the null hypothesis H0 mu equal to 3 in favor of the alternative hypothesis, and we accept the alternative hypothesis H1 mu is less than 3. The test statistics is less than the corresponding value. Here an example. Find the critical value for a left tail t-test where alpha is equal to 0.012. First, subtract alpha from 0.5. Thus, 0.5 we get a value. Using the t distribution table t, we obtain 2.26. However, the left tail test, the t value is minus 2.26. So the critical value is minus 2.26. Two-tail test. Here we are going to explain the two-tail test. In the early two slides, we discussed about one-tail test for right and left. Here, putting together both together, what we called as a two-tail test. Here, there are two critical values for the two-tail test. Here, the null hypothesis H0 mu equal to 3 versus the alternative hypothesis H1 mu is not equal to 3. 1 for the left tail denoted as t alpha by 2 with n minus 1 degrees of freedom, and for the other right tail test denoted by t alpha by 2 n minus 1 degrees of freedom. Here, the t value can be computed through the property of the left of its alpha by 2 and the value of t with alpha by 2 comma n minus 1, which gives the t value such that the probability to the right of it is alpha by 2. It can be shown using a t table, that is the critical value can be computed as t of 0.025 comma 14, which is minus 2.1448, which can be computed as given here. Rejection of critical region. The significant level decides the probability of rejecting a null hypothesis. Consequently, to represent the critical region on the distribution for a test statistic, shaded portion of the distribution gives a significant level of 5% or 0.05 of the corresponding distribution level of significance. In hypothesis testing, the level of significance is the important measurement that may be fixed either by 1% or 5%. The level of significance is used to compare with the p-value to decide whether to accept or reject the null hypothesis. Students, let us summarize what we have learned in this video. In this video, we come across how to define the test statistics for the critical region. In critical region, we discuss about one-tail test and two-tail test. In one-tail test, I said about the right tail, left tail, and in two-tail, we said about both shaded region. Students, we will continue in the next video. Thank you.